Okay, so this question asks for the potential difference across the 1 ohm resistor. So we realize that we have three sources, right? We have one voltage source with 5 volts, another current source with 2 ampere, and one voltage source with 4 volts. So that would mean that we have to do three scenarios, right? Three cases, right? Turning each one on and the rest off in each scenario. So in this first scenario, let's turn on the 5 volts and turn off the 2 ampere as well as the 4 volts, right? And then in the second scenario, right? So in the second scenario, let's so you turn off the 5 volts, right? You turn on the 2 ampere and you turn off the 4 volts. And in the third scenario, we turn off the 5 volts, we turn off the 2 ampere, and we turn on the 4 volts. So let's consider the first scenario. So what does it look like? In the first scenario, we have your 5 volt battery that's on, right? And you have a 3 ohm resistor. Then you have the 2 ampere, which will leave, and then since your 2 ampere is off, you have 0 ampere, right? Which means there's an open circuit because it's an open circuit has 0 current flowing through it. Then you have 1 ohm resistor, you have 5 ohm resistor, and finally we have 2 ohms. And then in order to turn off the 4 volts, we need to turn it off to 0 volts, so that's short circuiting it. So yeah, that's the first scenario. So what's the voltage across the 1 ohm resistor in the first scenario, right? The voltage is going to be this side positive, this side negative, right? So the voltage, yeah, so in order to do so, we need to find the current flowing through the circuit. So the current flowing through the circuit, so first of all, we notice that the 2 and the 5 here are parallel. So 2 ohm parallel 5 ohms is going to give you 1 over 1 over 2 plus 1 over 5. And that's going to give you 1 over 1 over 2. Punching into the calculator, we get 10 over 7. 10 over 7 ohms. Okay, so then from there, we realize that the 3 ohm, the 1 ohm, and the 7 ohm, the 10 over 7 ohm, they are all in series. So we sum them up. So we have 3 ohm plus 1 ohm plus 10 over 7 ohm equals to 38 over 7 ohms. Right. So so finally, right, by voltage divider principle, the PD across 1 ohm resistor is going to be 1 ohm divided by 38 divided by 7 ohm times 5 volts, and that's going to give you so that's going to be 1 over 38 over 7 times 5, and that is 35 over 38 volts, which also equals to around 0.921 volts. Okay, so we're done with the first scenario. So this is noting the sign, right? It's the positive is on the left and the negative is on the right. So that's the first scenario. So let's move on to the second scenario, right? What happens when we turn this 2 ampere on and the rest are off? So we start off with like this. We have a 3 ohm. Then we have your 2 amperes pushing 2 ampere through that branch of the circuit, right? So this 5 volts, since it's off, right, it's going to be 0 volts. So you join it with a short circuit. Then you have your 1 ohm and you have a 5 ohm, 2 ohm, and lastly, the 4 volts off, so we're going to join it with a short circuit like this. Okay, so so the first step would be to calculate the current. So the current 2 ampere is flowing in this branch, and we know that 2 amperes flow through here, right? And then it splits up into two. So it splits up into two. So there's one branch through here and one branch through here. So the current flowing through the 3 ohm plus the current flowing through the 1 ohm branch, right, is going to equal to 2 ampere. Yeah, and additionally, we know that the PD across this entire branch, right? We know the PD across this entire branch. We know the PD across this branch here is the same PD across the 3 ohm. So yeah, so what's the effective resistance of this setup? Effective resistance of this setup is this part is going to be 1 ohm plus the 5 and 2 in parallel, which we calculated previously with 10 over 7. So that's going to give us 17 over 7 ohms. So we know that 3 ohm times 3 times I across the 3 ohm one plus, sorry, it equals to 17 over 7 times the current across the 1 ohm, right? So substituting this back into here, right? Okay, so first let's make 3 ohm the subject of the formula. So solving for 3 ohm, we get 17 over 21 I of 1 ohm. So substituting this expression back into here, we get 17 over 21 I of 1 ohm plus I of the 1 ohm equal to 2 ampere. And solving for that, get so 17 over 21 plus 1, 2 divided by that, that gives us 21 over 19 ampere, right, which is approximately 1.11 ampere. Yeah, so the voltage across the 1 ohm is then 1 times that, right? 1 ohm times the current across it, V equals to IR, we get 1.11 volts. So that is the voltage across the 1 ohm in the second scenario, right? And once again, taking care of the sign, we realize that the left of it is positive and the right of it is negative. So let me just mark in green. Right, so the left is positive and the right is negative because the current is flowing from left to right. Okay, so let's think of this last scenario where we have the 5 volt and the 2 ampere is off, right? So looking at this diagram, these two will be off, right? And the 4 volt one will be on. So what would that look like? 5 volt one being off with a 3 ohm, and the 2 ampere is off, so it is open circuit. So 5 volt becomes 0 volts, 2 amp becomes 0 amp. So redrawing the circuit with the sources being this, so 4 volt that. Okay, so we have a 3 and 1 being in series, so that forms 4 ohms. So first of all, that forms 4. So 3 and 1 being in series, that gives you 4 ohms, right? Then on top of that, we have the 5 ohms parallel with 4 ohms. So then with 5 ohms parallel to 4 ohms, that gives you 1 over 1 over 5 plus 1 over 4. That gives you 20 over 9 ohms. So that's this part over here. So then your 20 over 9 is in series with your 2. So that gives you that gives you 38 over 9. So the if total resistance of all 4 resistors, right, in the series parallel series configuration is 38 over 9 ohms. So that will give us, that will let us calculate, yeah, so in order to find the PD across these two parts, right, so in order to find the PD across these two parts, right, we need to take the effective resistance of the 3, 1, and 5 over the total resistance multiplied by 4. So that's going to give us, so we have 20 over 9 for the 3, 1, and 5 over 38 over 9 multiplied by, so the PD, the green PD, right, across the 5 ohm one, the one in green, is going to give you this times 4 volts. So that's 20 over 38 times 4. That's going to give you 40 over 19 volts. Yeah, so from there, so then from there you can calculate the PD across the 1 ohm, right? So PD of the 1 ohm is equals to 1 over 4, right? 1 for this resistor over 4 being the total resistor, the total resistance. So once again, voltage divider principle multiplied by the PD across the total 4 ohms. So that's going to give you times 1 over 4, 10 over 9. 10 over 9, sorry, 10 over 19, yeah, 10 over 19 volts, which is approximately 0.526 volts. Okay, so noting the sign where, because this side is, because the green one, right, for the green one, your positive is here and negative is here, which means that when the current flows through the 4 ohm part, right, it's going to create a PD where the right side of the 1 ohm is positive and the left side is negative. So it's different from the other two signs. So the other two, for the first and second scenario, your left side is positive and the right side is negative. Left side is positive and right side is negative. But in this case, the left side is negative and the right side is positive. So it's the opposite. So taking all these results, right? Taking all these results, so yeah, so the total PD, so V total across 1 ohm is going to be, right, 35 over 38 plus 21 over 19 minus, right, because this one has the opposite polarity, right, minus 10 over 19. And that's going to give us 1.5 volts. So that is your PD across the 1 ohm resistor, where the left side, right, so the left side, so your 1 ohm resistor is like this. The left side is 1.5 volts higher than the right side, right? So yeah, your left side is 1.5 volts higher than the right side. So that's the direction and sign of the, that's the magnitude and the direction of your voltage across resistor 1.